Hello, this is Ms. DB. In this video, we are going to look at simplifying radical expressions. There's a couple videos in your textbook already that explain how to write a radical in rational expression and how to write a rational expression in radical form. So I'm not going to go into that too much, but I do want to go over how to evaluate or how to simplify them. Evaluate means to find an answer. Simplify means to write it in simplest form. So there's a little bit of a difference there. So let's look at number 5. Number 5 says first to write as a radical, then to evaluate in that radical expression. So to write as a radical, as you've probably already watched from your book, the bottom number tells you what to put inside that little part of the root there. So this will be the 5th root, and it's the 5th root of 1024. Now, to evaluate that means to find the number that to the 5th power is equal to 1024. And you probably don't know exactly what that is right away. But we can try some numbers. We have a calculator, and we could try 2 to the 5th, 3 to the 5th. These get big so fast that you won't have to go very far before you find your answer. It's going to be some integer number inside there that to the 5th power equals 1024. So at that point, it's really a matter of trial and error here. So 2 to the 5th is going to be too small. That's 32. 3 to the 5th is 243. 4 to the 5th power is it. 4 to the 5th power is equal to 1024. So 4 is the number that's in there. So when you evaluate, the 5th root of 1024 is equal to 4. Let's look at the next section. Again, is covered by a video, how to write a radical in rational form. But I want to look at some of these on this page about, it says first to write in radical form and then to write in the simplest radical form. So you might not be able to get a nice answer like 4 like we did for that one, but we'll be simplifying them. So some of them, like the square root of 24, this is the same exact thing as you did on the last worksheet, simplifying a square root. And number 11 is also going to be simplifying a square root once you rewrite it that way. But what about something like 12? It says the 5th root of 96. This is already in radical form, but they're saying write it in simplest radical form. Let's write 96 as a product of its factors. So 96, it looks like that is going to be divisible by 3. Let's see what 3 times 32. So I'm going to write the prime factorization of this and see if that helps me. Now 32 has lots and lots of factors. Let's see, we could write it as 4 times 8, and 4 is 2 times 2, and 8 would be 4 times 2, and then 4 is 2 times 2. So I'm going to rewrite 96 as its product of its prime factors, all of these at the very bottoms of the trees. So this is the 5th root of, and if it's easier for you to write, if you're typing, and you want to write it to the power of, to the powers of are a lot easier to type because you can just use the exponent key, you know, the superscript key, and then you can type a fraction using the division sign. Okay, so this is 3 times 2 times, how many 2's do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it's the 5th root. So if there's 5 of them and you want the 5th root of 32, or the 5th root of all of these 2's, is 2. So that means that of all of these, the 2 comes out, and all you're left with is the 5th root of 3. Or you could write it as 2 times the 3 to the 1/5 power. So the 3 will still be inside of that radical, and it'll still be to the 5th root or to the 1/5 power. The 2, however, because the 5th root of 32 is equal to 2, then that gets to come out of the radical, and you just write it like that. All right, let's look at another one that's not a square root. Number 13 just to be clear, you're going to simplify the square root of 240, and you're going to simplify the square root of 567 if possible. Oh, I think that's divisible by 3, so you might want to start there when you're looking for factors. Just double check 567 divided by 3, 189. Yep, so this one has 9 as a factor. So that's a perfect square, and there might be other perfect squares in there too, I'm not sure, but that's a hint. Let's look at number 15. That looks crazy. So we have the 6th root of 64x to the 8th. There's an x in this one. This is the only one with a variable thrown in, although we will see this kind of thing later. So I'm going to start by writing 64 as its product of primes. 8 times 8, right? But 8, well, we just did 8 up here. 8 is 2 times 2 times 2. Or you can do 4 times 2 and then break it down. And we got another one of those. Look how many 2's we have. 1, 2, 3, 4, 5, 6. The 6th root of just the 64 part is equal to 2, because it's the 6th root of 6 2's. 3, 4, 5, 6. And that you're undoing it. So you get just 2 for that part. And now you have to take the 6th root of x to the 8th. A little more room here. So x to the 8th, square root of x to the 8th. Should we write that out? That means how many x's are in here? There's 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. Well, 6 of them, when you take the 6th root of x to the 6th, that's x. There'll still be 2 left over, though, that didn't get to be simplified. So the 6th root of x to the 8th is equal to the 6th root of x squared, and the x got to come out. So the x would be in front with the 2. So this would be 2x. If you want to use the radical form, it would be x squared to the 1/6. That one's kind of crazy. So again, when you're simplifying, you're writing them in another form. You're not going to get a nice, neat little answer when you're done. And you can see some of these are a little bit complex. But do the best you can. Look for the index, the 3 or the 6 on this one, the 6th root, or the bottom number of the fraction, tells you how many of those factors you need in order for you to be able to simplify that part. So the 6th root of 64, because it was 2 to the 6th power, and the 6th root undoes 2 to the 6th, and you just get 2. And then the last part is a little bit simpler. You just have to match the radical expression to the rational expression. So these are fractions over here. They're a little bit hard to read. You might have to increase your screen size. There we go. So we've got 7 to the 3/2 here, 600 to the 1/3, that's an exponent, 51 to the 3/4, and 2 to the 5/5. And then you'll be matching them to the radical expressions on this side. And remember, there are also 2 other videos in the section in the book that explain how to do 6 through 9 and 1 through 5 more. Well, 2 through 5. Number 1 is explained at the beginning of the section in the reading part. Thank you very much. Let me know if you have any questions, and have a wonderful day.